Hello student and welcome to the course Urban Rail Transit Tracks, Stations and Yards. Today, we're going to learn the last part of the railway tracks, subgrade. Before we officially start this part, let's take a brief review about the track bed. As a critical component of the railway system, track bed is responsible for providing stability, load distribution, and proper alignment for the tracks and trains. Generally, track bed consists of sleepers and ballast to distribute stresses and absorb vibrations. However, disadvantages of ballast like intensive maintenance, limited speed, and deformation make ballasted track less attractive. Non-ballasted track, therefore, offers a promising alternative for railway engineers seeking improved performance and reduced maintenance burdens. The track bed relies on the subgrade for its structural integrity and stability. But if the subgrade is not properly engineered or maintained, it can lead to track bed deformations, misalignment of rails, and even derailments. A railway subgrade is a critical foundation designed to support the train tracks and ensure smooth railway operation. It serves as a long, flat structure laid on the ground, and its construction may involve digging or adding materials to shape it correctly. Maintaining the right track height during construction is crucial to ensure the seamless connection with bridges, tunnels, and other railway components, facilitating safe and efficient train travel at appropriate speeds. The subgrade bears the weight of both stationary and moving trains, enduring various environmental factors. Its strength, stability, and resilience are paramount for railway safety. Stability ensures that the subgrade remains intact despite the train and natural forces, while strengthening enables it to support the heavy train loads without damage. Additionally, its resistance to water and temperature changes is essential to maintain its structural integrity, even when subjected to fluctuating conditions. This comprehensive performance ensures that the subgrade remains robust, impervious to train and environmental impacts, and adaptable to water and temperature fluctuations. The design process for the subgrade begins with the creation of this cross-sectional profile. This involves determining the shape and dimension of various components within the cross-section, essentially like visualizing and cut through the foundation from one side to another, known as cross-section. Subgrade is a naturally occurring soil which is prepared to receive the ballast. The prepared flat surface, which is ready to receive the ballast, sleepers, and rails, is called the formation. The formation is like the solid foundation of the railway track, and is super important because it does several crucial jobs. First, it gives us a nice, even surface to put the tracks on, making sure they are level and smooth. Second, it's strong enough to handle all the weight from the trains, which get passed down through the ballast. Third, it helps the water drain away so our tracks don't get all smoggy and unstable. And finally, it keeps everything steady so our trains can run safely and smoothly. So, think of the formation as a strong supportive base that keeps our railway tracks in good shape. The formation can be prepared either by providing additional earthwork over the existing ground or by excavating the existing ground surface. There are 6 different forms of formations that shape the ground to get it ready for the train tracks. When the formation is in the shape of the raised band constructed above the natural ground, it is called embankment. Imagine adding materials to the ground to build a sort of raised pathway for the tracks. This way, the tracks end up higher than the surrounding ground. The formation at the level below the natural ground is called a cutting or excavation. When there's a cutting or excavation, it's like making a big trench in the ground to create a space where the tracks can fit. It's used when the ground is higher than where the tracks need to be. Normally, a cutting or excavation is made through the hilly and the natural ground for providing the railway line at the required level below the ground level. The side slopes of both the embankment and the cutting depend upon the shearing strength of the soil and its angle of repose. The stability of the slope is generally determined by the slip circle method. In actual practice, average soil such as sand or clay may require a slope of 2 to 1 horizontal to vertical for an embankment and 1 to 1 or 0.5 to 1 or even steeper, particularly when rock is available for cutting. To provide erosion of the side slopes due to the rainwater, etc., the side slopes are turfed. A thin layer of cohesive soil is used for this purpose. Alternatively, the slopes are turfed with a suitable type of grass. Sometimes, the bank also gets eroded due to the standing water in the adjoining land. A toe and a pitching are provided such cases. The height of the formation depends on the ground contours and the gradients adopted. The side slope of the embankment depends upon the shearing strength of the soil and its angles repose. The width of the formation depends upon the number of tracks to be laid, the gauge, and such other factors. Now, things get interesting with most embankment and most cutting. Imagine the ground is sloping to one side. Mostly embankment means we add a lot of materials on that slope side to make it level for the tracks. On the other hand, mostly cutting means we dig down on the sloping side to make a space for the tracks. Embankment and cutting, also known as a cut and fill, is a bit like balancing. It's when we add material on one side and dig on the other to even things out. Imagine one side of the tracks being built up with soil, while the other side is dug into the ground. This creates a balanced track foundation. Lastly, there's non-filling and cutting. This is the easiest one. It's like finding a perfect spot for the traffic ride on the natural ground. No adding, no digging, just placing the tracks where the ground is already good to go. It's as if the tracks are made to fit right into the ground without any changes. All of these forms help us make sure that the trains are safe for the trains to travel on and it creates a smooth path for them to move at the right speed. As we wrap up this lesson, we covered the significance of railway track backs, focusing on the subgrade and formation. The subgrade bears the weight of the trains and must be strong, stable, and resilient. The formation provides a level and sturdy base for the rail tracks, promoting proper drainage and ensuring safe train travel. We explored 6 formation types, such as embankment and cutting, each tailored to specific ground conditions. These methods ensure a stable foundation for railway tracks, accommodating various landscapes. Alright, that's all for the lesson today. Stay tuned to learn more about urban rail transit tracks, stations, and yards.